Welcome back to the series of The Calculus of Friendship by Steven Strogatz. In this chapter, Steve has discussed about how if one is mindful might land up in doing things that one is passionate about. As they say, when your passion is your job, success finds you in ways you have never ever imagined. There are a number of people who just followed their passion. Actually, they devised their own ways to follow their dreams. Say, Bill Gates, an exceptional math student, used to play with the then available PDP-10 computer and started learning coding during the age of 13, and that too only during the lunch break, which has actually led to the Microsoft creation, and the rest is history. And Disney spent his time drawing from an early age to launch several unsuccessful animation companies before coming up with Mickey Mouse in 1928. And Steve Jobs, in a commencement address to a graduating class in Stanford University, says,
To do what you believe is great work. And the only way to do great work is to love what you do. If you haven't found it yet, keep looking and don't settle. As with all matters of the heart, you'll know when you find it. And like any great relationship, it just gets better and better as the years roll on. So keep looking, don't settle.
Similarly, Steve Strogatz, the author of this book, also has his own interesting story. This is about 42 years ago, while he was in his first year of university. He was a bit demoralized when he was doing linear algebra course. So he was in a confused state if to switch to physics. But he was fortunate to have a good teacher for complex analysis course, so he continued with math major. But looks like his family and his extended circle had always felt that Steve should be a doctor. So, after running a self introspection test, Steve took a plunge into pre med, which he feels as an irrational step, though he was sure that he wanted to be a math professor. This is when, that is during 1978-79, Steve wrote to his teacher Geoff about one of the most interesting numbers in math, though he never touched upon the dilemma that he was undergoing about his majoring. In this letter, he succinctly talks about square root of 2, which is popularly known as the first crisis of mathematics, and this being the first irrational number as well. Before going further, let's start by quickly recalling what is an irrational number. If a number can't be expressed as a fraction of two integers and not having a common factor that is incommensurable, and also if the decimals keep on going, then we call that number as irrational. Historically speaking, square root of 2 dates back to few millenniums ago, that is easily 4000 years back, when Babylonians during 1800 to 1600 BC gave the approximation of square root of 2 up to 6 decimal places, where they used base 60 as shown here in this tablet. Then Indians in their Vedic text, that is Bodhayana written during 800 BC, Apastamba written about 600 BC, and Katyayana and Madhava sometime during 200 BC, which are collectively known as Sulba Sutra. And the approximation of square root of 2 has been well provided here. And interestingly, they are found detailing the geometry necessary for designing and constructing the fire altars for religious rituals. According to this, they have arrived till 7th decimal place, which is correct to 5 decimals, that is 1.4142156. The calculation given by Bodhayana, written in Sanskrit, states Samasyad vikharani pramanam tritiyena vardayet tat chadurthenatma chadustrim shonena savisheshaha, which translates to increase a measure by a third and this third again by its own fourth, less its 34th part. This is the length of the diagonal of a square. And this refers to this equation, which is square root of 2 approximately equal to 1 plus 1/3 plus 1/4 of 1/3 minus 1/34 of 1/4 of 1/3. Then came the Pythagoreans, who changed the world of mathematics into a different perspective. That is, pre-Greek times, mathematics was generally used as a practical purpose, created to deal for basic daily matters such as measurements in terms of counting, then measuring area, volume, weight, and for economical aspects, and also for time estimation. And like we saw in Indian Vedic texts, which they have used extensively for religious purposes. And it was Greeks who saw mathematics beyond practicality and as a knowledge dimension. Pythagoras during 6th century BC drove the inspirations from the order and harmony of nature around us, that is, say, from the laws of musical harmony to the motion of planets. And according to Pythagoreans, number rules the universe. And by number, they meant natural numbers and their ratios. Everything else, that is, negative numbers, irrational numbers, and even zero, was excluded. Unfortunately, there was a disciple from Pythagoras' school named Hippasus who discovered that square root of 2 cannot be written as fraction, which actually was a big blow to the ancient Pythagoreans school of thoughts. And it is believed that after Hippasus mentioned about his discovery, he was not found. Some say they drowned him in the middle of the ocean, some believe he was left alone in an island, so not sure which is true. But anyways, maybe that's why if someone speaks something contrary to the conventional wisdom, she or he is called as irrational. But nevertheless, if the idea or concept or moral is right, one should not evade spreading the unconventional knowledge which may totally flip the coin of our understanding. Otherwise, we would not be having square root of 2 or pi or e to name a few. And moving on to the proof, square root of 2 is typically proved in an elegant method, that is by proof of contradiction. That is, writing ratio of two integers x by y, which means that 2 is equal to x square by y square, and so x square is equal to 2y square. So obviously x is an even number. And if we take x as 2p and substituting this in this equation, we get 2y square is equal to 2p the whole square, which again yields to y square to be twice p square, meaning y is an even number too. So resulting in x by y having a common factor which is contradicting to the original requirement that it doesn't have common factor. Hence they are called as irrational. This could also be proven geometrically, which Steve has explained it in his own style and it is quite enjoyable. Say, let's fold the square along the diagonal, where we will have an isosceles triangle. In this, let's consider the length of the side to be multiples of unit length, say 1. From this, a sequence of isosceles triangles are constructed with diminishing sizes, breaking it down into smaller isosceles triangles. And at some point where hypotenuse will be less than 1, that is no integral multiples of L, thus no such L could exist. And so hypotenuse and sides are incommensurable. This is an interesting proof, isn't it? So when we talk about the square root of 2, one might remember the standard sizes of paper that we use in majority of the countries around the globe. That is the A4 size, which is 210 mm by 297 mm. The largest sheet from the A series is A0 size, and it has an area of 1 meter square and the dimensions are 841 mm by 1189 mm. And this A series A0, A1, A2, A3, A4, etc. uses an aspect ratio of 1 is to square root of 2, and other sizes in the series are defined by folding the paper in half parallel to its smaller sides. For example, cutting an A4 in half along the longer side will create two A5 sheets and so forth. The square root of 2 has many such beautiful properties. During this year, that is 1978-79, is when Steve has been wobbling over subjects, choosing pre-med subjects, though his heart was all the time to become a math professor. And so after experimenting for about a year and having quality discussion with family members, he discovered what is right for him. But beginning with irrationally enrolling subjects which were not his cup of tea. So he wrapped up this chapter with this line which I loved the most. Some people never find their passion, but by denying mine, I found it and became sure of it. The above geometrical proof brings in the puzzle for this year. Numerically interesting year, so to say, as 2021 is not just the concatenation of consecutive integers 2021, but also could be written as a product of two consecutive prime numbers 43 into 47. So the question is, how would you construct a square from a rectangle without changing the area of the rectangle, which is 2021 square units? Please share your thoughts. Happy and healthy 2021. Thanks for listening.